Hi, everyone. Thank you for joining us today. Presenting to you all is Kelly Roberts, who is the Sustainability Lead for the Structures practice here at Walter P. Moore. For those of you that have not joined us in the past and who may not be familiar with Walter P. Moore, we are an interdisciplinary engineering firm, provide structural engineering, forensics, and infrastructure services. We work on various project types like stadiums, office buildings, airports, schools, among other projects. So we hope you enjoy the presentation today. If you have any questions, please type them into the chat and we will address them during the presentation. So with that, I'll hand it over to Kelly.
Thanks so much. Good afternoon, everyone, and thanks for having me. As Anne mentioned, I am a principal and project manager at Walter P. Moore in our Atlanta office, and I also lead the sustainability group for the structures practice. I'm really happy to speak to you about my passion for sustainable design and low carbon buildings. But let me start with just a brief background in how I got into structural engineering and then how I just developed a specific passion for sustainable design and low carbon buildings. So I got into structural engineering because it's a family affair. So my grandfather was an architect in Cuba, and he loved buildings and building design. And he immigrated to the United States in the 60s when a lot of Cubans came over. And he and my father ended up founding and working at a metal building manufacturing company. So my father runs that company today. But I spent a lot of my summers working there, learning how to draft, learning basic engineering. And I also just spent a lot of my time listening to my father and grandfather talk about their love for buildings and architecture. And I spent a lot of time just looking at buildings. There isn't a building now that I walk into and I don't look up and around and just kind of look at the structure, see what's there. And look at the architecture. I love the built environment. I love skyscrapers, but it's just been a part of my entire life. So I ended up going to Auburn University, and and while I was at Auburn, I studied both civil engineering and then structural engineering. And while I was working there, I got to work on a project where we were using self-consolidated concrete, which is this really cool type of concrete that's really flowable, and it almost acts like water and it just flows into forms. But as part of that concrete, what they also do is they use a lot of supplementary cementitious materials, which are materials that you can use that are byproducts from other industries that act like a cement but aren't cement. And what that leads to is a really high recycled content. So I thought that was really cool, and that was kind of my first entry point into sustainable design. Over the years, I've had the opportunity to work on some amazing projects. Some of them I've shown here, from 80-story towers in Saudi Arabia to the Center for Civil and Human Rights here in Atlanta. And then, I'm showing a 40-story building here with a cantilevered glass bottom pool that's in Houston. And then the State Farm development that's up at the perimeter here in Atlanta. This is a massive development, and I spent a good portion of my life working on it. And the thing about all of these is that I've been learning a lot along the way when it comes to sustainability. I've learned that structural engineers can have a huge impact on our environment, and it's up to us to ensure that we impact it in a positive way. I strongly believe that we have to impact every single project in a positive way. And we owe this to our future generations to do this. I'm a mother as well. I have two boys that are 5 and 2, and then I'm due in 2 weeks with a third boy. And I know I owe it to them to leave this planet better than I found it. And so for me, this is really where my passion for sustainability comes from, a desire to leave this world better than I found it. And to always do the right thing to the best of my ability. So this is the impact that structural engineers can have on our environment. As an individual, we can have the best of intentions to reduce our carbon footprint by reducing the amount of flights we take, becoming a vegan, or driving an electric car, or riding a bike to work. But what really matters as an individual structural engineer is our material specifications. It's what we put into our buildings, the materials that we use, the concrete and the steel and the wood. All of that is really, really impactful. And so the decisions that we make every day as structural engineers are what really matters. We have a really unique impact on the environment, and we need to take it seriously. We can make a really big difference. So we'll dive in here about what are carbon footprints. So carbon footprints are the total amount of greenhouse gases, including carbon dioxide and methane, that are generated by our actions. For a building, the carbon footprint is all of the carbon generated by these three buckets: embodied, operational, and transportation carbon. Transportation impacts are all the impacts related to, of course, the transportation to and from the building. Operational is all the energy or carbon it takes to run the building. But today I'm going to be mostly speaking to you about embodied carbon, because this is the piece that is largely within my control as a structural engineer. Embodied carbon has to do with all the materials and products used to construct the building. It's all of the carbon dioxide emitted by extracting, manufacturing, transporting, and installing materials. And it's not a small amount of carbon. Every year, 66 billion square feet of buildings are constructed, and the embodied carbon emissions of that construction is approximately 3.8 billion metric tons of CO2 per year. That's a lot of carbon. In fact, we're building so much that we're actually building a new New York City every month for the next 30 years. And between now and 2050, we're going to add 2 billion people to the planet and close to double the square footage of the built environment. So next, I'm going to play a little video, hopefully it works, from Bill Gates. And he's going to talk about basically the basics of embodied carbon. So let's watch.
Well, let's talk about climate change. Now, people think, hey, aren't we getting the solar panels and windmills to be a lot less expensive? And isn't that helping reduce greenhouse gases? And the answer is absolutely. But there's a lot more to do than just taking electricity to zero emissions. There's a variety of things that generate greenhouse gases. We have a lot of sectors of the economy, like manufacturing, that are emitting greenhouse gases that aren't talked about as much. Manufacturing, everything we make, even a cute little squishy like this, that's emitting 21% of the greenhouse gases. The number of buildings in the world is going to double by 2060. It's like we're going to build a new New York City every month for the next 40 years. It's a gigantic amount of materials. Steel, cement, wood, all emitting greenhouse gases. We're going to have to figure out how to make all these things in a different way. And so we're going to need a lot of change, a lot of innovation to bring the emissions from all those areas down to zero.
So I think that's a great video that kind of sums up what we're dealing with. You know, all the little squishies and all the things we're making, they all have embodied carbon. And for us in the building industry, there's a lot of embodied carbon because we're dealing with really highly impactful materials like concrete and steel. And so we need to figure out how to reduce our impact. And we know that if we carry on with our business as usual, the International Panel on Climate Change shows that we will well overshoot the goal of staying below 2 degrees Celsius. That's the goal. We don't want to increase global warming. We want to stay below that 2 degrees Celsius threshold. And in order to do that, we need to change the way that we're doing things. So looking at this a different way, these graphs are from Architecture 2030. It's a group that focuses on sustainability in the built environment, a group of architects that are really focused on this. We know that buildings alone account for 40% of global greenhouse gas emissions. And 28% of that is from operational, which is largely where the focus has been, and rightly so, because it was a bigger piece of the pie. But the thing is that as we've driven down operational emissions by putting PV panels on the roof and focusing on reducing the operational impact of the building, we've needed to make a shift to focus on the 11% that's due to embodied carbon. And the critical thing about embodied carbon is that it happens day one when the building opens, and it never gets reduced. There's no future efficiency that'll drive it down. You can't decide, okay, let's put PV panels on the roof and in any way affect the embodied carbon that's already there. It's there when you build the building. It's there when you construct the steel frame. It's there when you pour the concrete, and there's nothing you can do about it later on. In the next 30 years, the critical time period, according to the International Panel on Climate Change, embodied carbon will account for half of new construction carbon. So as we approach 2050 and we try to decarbonize the building industry, we can't get there without focusing on this piece of the pie. The breakdown of embodied carbon can vary kind of wildly from project to project based on the size and materials. You know, all buildings are really very different. But we know a couple things. We know that most of the emissions are from structure, most are from steel and concrete, and most of the impact from concrete is from the cement. And of course, cement is not the same thing as concrete. Cement is a part of concrete. Cement is to concrete what flour is to a cake. It's just one of the components. It's the binder. Concrete also includes aggregates or rocks and sand and water, air, and admixture. Cement actually makes up only 12% of the weight of concrete, but it's responsible for 95% of the carbon emissions. It's the second most consumed resource in the world after water, with more than 4 billion tons produced globally every year, and it accounts for 5 to 8% of global carbon emissions. The reason this material is so carbon intensive is because it takes a lot of energy to produce, and it produces CO2 as part of the reaction. So it's a double whammy. But in many cases, we can actually use less cement, and we really should try. And I'll talk a little bit more later about how we try to use less cement in our designs. And if you're looking for more information on concrete and embodied carbon, search YouTube for these Girl Scouts. This topic has gotten so mainstream that even the Girl Scouts are talking about it and concerned about how we're going to reduce the embodied carbon in building materials. So let's pause here for some questions and discussions, and we'll get into what the building industry has been doing about embodied carbon and what you can do.
So Kelly, what is the biggest hurdle in the building industry when it comes to sustainability?
So I think it's just thinking that we should always do things the same way. You know, a lot of the building industry, they just want to do what they did yesterday because they know it works, they know it's safe, they know they can get those materials. So trying to think outside the box is one of the biggest hurdles in sustainability. Trying new things is one of the biggest hurdles.
And so how often do you speak to clients or architects or people that are deciding, you know, whether a building is more sustainable or not? How many times a week do you kind of make this pitch as to why we should be more sustainable in our approach to building?
Yeah, so I talk about this almost every day because that's part of what I do is lead these conversations. So I'm having sustainability conversations every day, and there's a lot of people that are discussing this all the time. Since I know that we're speaking to a student crowd, I want to assure you that the industry is focused on this. We are having these discussions on our projects. We are trying to figure out how to make things better, how to make our buildings better, and how to come up with new ways to address these problems.
Great. So let's continue, and I'm sure you're going to share more about different organizations that you're a part of and other things that you're doing to kind of progress the industry to a more sustainable future.
Yeah. So let's see what the industry's been doing about embodied carbon. There's been a groundswell of discussion and advocacy around embodied carbon in the last couple of years. In 2019, the World Green Building Council released the Embodied Carbon Call to Action report. This is the first call to action that really started to name all the stakeholders involved in embodied carbon and task them with what they can and should do about embodied carbon with deadlines. Architecture 2030, a group I mentioned earlier, is a leader in this space. They first issued the 2030 challenge for all new buildings, developments, and major renovations to be carbon neutral by 2030. But this only dealt with operational energy. So they issued a 2030 challenge for embodied carbon to be carbon neutral by 2050. This was an add-on that they provided. So then also the American Institute of Architects, or AIA, has AIA 2030, which is a commitment to the 2030 challenge issued by Architecture 2030. They've also made a commitment to materials as well and increased their attention to embodied carbon. Another organization that's a true leader in this space is Carbon Leadership Forum. This is a group that's solely focused on embodied carbon and have been doing some really incredible work for a long time. If you're interested in learning more about this topic, I really encourage you to check them out. There's a wealth of information on their website. And then in response to the growing importance of embodied carbon and to complement all of these other organizations, an initiative called SE 2050 was created within the Carbon Leadership Forum and then adopted by the Structural Engineering Institute. SE 2050 is specifically a challenge for structural engineers to push for carbon neutrality by 2050. So it's obviously becoming a really big deal, but what can we actually do? The first thing that we can do is understand our impact and then reduce our impact. So we do this through a process called life cycle assessment. It's an evaluation of all the environmental effects of a material or process from the initial gathering of the material from the earth until at the point at which all residuals are returned to the earth. It's an ISO-governed process, which means that there are governmental agencies that kind of govern what this process looks like. And we look at all phases in the life cycle of the material, from the harvesting of the material through manufacturing and construction to demolition and disposal. And then we look at multiple environmental impact categories, including greenhouse gases or global warming potential. So we establish our baseline structure for our whole building LCA. We look at all of the structure and all of the enclosure. And then from there, you can also consider other elements like the carpet or the floor, or the ceilings and things like that. But at a minimum, we're looking at the structure and the enclosure. And then we put it into a software. So in order to actually perform the LCA or the embodied carbon analysis, you have to start with quantities. How much concrete, how much steel, how much wood is in your building. So we can usually get this from our building information model. We use a program called Revit in order to produce our drawings and to build 3D models. And then we can take all the quantities that are in those models and we put it into an LCA software. I've listed several here, such as Tally and One-Click LCA and Athena, to get the environmental impact of all these materials. And from that, you get this kind of output that shows, in this example, you've got a 1 and a 2. So you've got your baseline building, and then you have an improved building where you've made some decisions that are better. And it breaks down the impact by material. And then from this, you can use this to determine where your greatest impacts or your hotspots are. And then you can take a number of steps to reduce your impact. So these are some of the strategies that we use in order to reduce our impact. Things like specifying less cement. We can use supplementary cementitious materials like fly ash. That's a byproduct of the coal industry, or slag, which is a byproduct of the steel industry. These are things that are similar to cement, but not exactly cement, and they're basically recycled products because they are byproducts from other industries. So we can use those materials in lieu of using cement, which is really carbon intensive. Then we can also allow, we can specify each mix for its appropriate usage. And what that means is sometimes we want to say that we'll let our columns and foundations cure for a little bit longer, and they don't need to get strength so fast, so we can use less cement in those mixes. We can also use really cool technologies like carbon cure. Carbon cure is a technology where they inject CO2 that they've gathered from industrial sources into a concrete mix. And it not only makes the concrete mix stronger, but it also reduces the cement content. So we can basically inject that CO2 into that mix. It basically allows more concrete particles to form, and it reduces the cement content and actually sequesters carbon. So it's a really cool technology. And there's a lot of other really neat technologies that are available out there on the market. We can use salvaged materials, so materials that have been used in another application, maybe a steel beam or wood, different types of applications. We can better understand our supply chain. Sometimes just knowing that you're going to get your steel from a plant that runs on a PV grid versus a coal grid can really improve the embodied carbon of your building. So knowing all these things, repurposing existing buildings, trying to be really efficient in our designs, all of those things can help lower the embodied carbon of a structure. And we use this LCA thinking when we're coming up with our ideas for the types of buildings that we're going to design, and we can use them to decide which kind of structural system to use. So in this example, you have cast in place concrete and structural steel, and then two types of wood structures. And we basically looked at, where are the impacts for each of these, and can we make a decision for this building based on the lowest embodied carbon impact? So I think let's pause again for some questions, and then we'll just kind of wrap this up and talk about some available resources.
So Kelly, does the distance by which you source products, does that make an impact on the sustainability metrics for buildings?
So it can. It's something that we consider. So we consider the transportation impacts when we're doing a whole building LCA, but sometimes it's better to use a product that comes from farther away if it's lower carbon than it is to use a more local material that is higher carbon. It used to be that we just looked at regional and recycled materials. So we looked at attribute-based things. But now that we're doing whole building LCAs, we can take all of that into account. Lower carbon materials that are coming from further away versus higher carbon materials that are local. So the answer is it depends, and we consider that.
So do you participate in any of the organizations that you highlighted in the past section?
Yes, I participate in all of the organizations that I highlighted in the past section. Yeah, we are really active at Walter P. Moore with all of the industry organizations. We want to make sure that we're touching them all and basically staying in contact with all of those organizations that are having an impact on the way that we're looking at sustainability, about how we're addressing embodied carbon, and all the decision makers.
Great. All right, let's move on and talk about other resources available.
Okay. All right, so I wanted to point out a couple embodied carbon resources that you might find useful. The first resource is the AIA Framework for Design Excellence. The framework is made up of 10 measures, and it's intended to be really accessible to every architect for every project. But I think it's a great resource that deals directly with embodied carbon and best practices. And it's really kind of attribute based. So it just gives you best practices, best things to do on projects. So I think it's an easy to read resource that anyone could read if you're just interested in learning more about what architects and engineers are doing to address embodied carbon. The next one is a really interesting resource. It's the 2030 Palette by Architecture 2030. So this goes beyond embodied carbon. The 2030 Palette, it's a free online platform that curates information and practices and provides basically guiding principles for creating low carbon buildings. The sustainable design strategies address energy consumption and greenhouse gases at all scales, from regional and city planning to big building details to small building details that can even be applied to residential. But as part of the palette, there's a materials palette that was developed, and this is specifically for materials and embodied carbon. It's an attribute-based approach to embodied carbon reductions that identifies key attributes that contribute to a material's embodied carbon impact, and it offers guidelines and options for emissions and reductions. So the palette offers all sorts of great information on different materials and how to make them better or how to make better choices. So this is the insulation page, for example. So the insulation is like a sweater for buildings, right? It's the thing that goes on the outside that keeps buildings insulated. And this is basically a guide on the best types of insulation that you can use with respect to carbon. And it provides a list and says, you know, basically straw bale is the best and EPS is the worst, XPS is the worst. And then it tells you all about the whole manufacturing process of it too. So it's a really cool resource to find out about how materials are made, why they're carbon intensive, and what better choices are there. This is another free resource. It's the Embodied Carbon in Construction Calculator, or EC3. And you can basically build a whole building in here and you can see the carbon impact of that building and where you can make reductions, whether it be in the concrete or the steel or the carpet or the ceilings. It's a great tool to play around with, and it creates all these really cool kind of graphs, and it's free. So I recommend that you play around with this if you want to. And then this is just a really simple tool to get an understanding of what kinds of numbers we're talking about when we're talking about embodied carbon. This is called Ecom. It's the Embodied Carbon Order of Magnitude tool, and it was created by SE 2050. So at Walter P. Moore, we also wanted to contribute to the conversation, so we issued this embodied carbon report. And it's a clearer view of carbon emissions. And this report has all sorts of great articles and resources that really dive into embodied carbon and how we're tackling it as a firm. It has a lot of great project stories and best practices of what we're doing on our projects and how we're trying to make our buildings better. And that's all I really have for today, and I'd love to take any more questions and ask that you connect with us afterwards if you're interested in learning more.
Thanks, Kelly. A few questions before we sign off. How can you tell if a building is sustainable and made of whatever type of material? Is it easy to tell? Is it difficult?
Okay, so if you're thinking about just looking at a building?
Yes.
Okay, so it's not really easy to tell if a building is sustainable. For example, you may think a building made out of wood is really sustainable. Let's say it's mass timber, but it's really important where that wood came from. And that's one of the things that we look at when we're doing a whole building life cycle assessment, or when we're just talking about designing our buildings. It's really important where all the materials came from. You want to make sure that that wood, for example, was harvested sustainably in a forest where they're replanting trees. It's not very helpful if you take wood out of a forest and you put it in your building and then you don't replant the trees. That kind of stops the cycle right there. So it's really important that you look at all aspects. That's why whole building life cycle assessment is so important, because it really looks at the whole building holistically and doesn't just make assumptions about best practices. There are some best practices that you can do without doing a whole building life cycle assessment, of course. Some of using that 2030 palette is a good way to do some of that. Like using mineral wool insulation. There's always better choices that you can make, but it is important that within the better choices that you make, that you understand where those products came from.
And then can you talk a little bit about the LEED certification and how some buildings will have plaques in their lobby that indicate that it's LEED certified project and what that actually means?
Yeah, so LEED certified buildings are really an important part of this. LEED is a driving force in trying to get developers and architects and engineers to all kind of follow the same set of standards in order to create sustainable buildings. So it does mean a lot. It means that they've met a minimum set of thresholds and standards in order to create that building. It's a great starting point. I think that if a building is pursuing that, then it definitely means something. You don't always know exactly which things they did to get that plaque, but it is great when buildings pursue different rating systems, and there are quite a few. There's the Living Building Challenge, there's WELL, there's LEED, there's different ones that people can adhere to. And I think that pursuing, any and all of those is fantastic because it keeps everyone on the team accountable for maintaining minimum standards.
Great. So before we close out, what is one piece of advice that you might have for somebody pursuing a career as a sustainable engineer?
So I think, first of all, I think for anyone pursuing any career, it's follow your passions. It's always really important to follow your passions because that's where you're going to do the greatest work. And become an expert in something, follow that rabbit hole down a path and become an expert in your thing. That's what we really need in this world. We need a lot of experts that have followed a path and become the person in that thing. I know somebody that's, studying like fungi for buildings to help make them green. Be that fungi person, for me, I've really focused on sustainability in concrete, and that's my focus. So I think it's really important that you just follow your passions, become an expert in something, become well-versed in something. And then I think you'll just be a great contributor to society if you do that.
Great. Thank you. So I think that wraps it up for today. Please join us for our next session, which is going to be July 27th at 5 p.m. Eastern, and our presenter will be Kat Chan. So thank you all for joining us today, and we hope to see you again soon on another one of our sessions.